In this session, we are going to discuss various types of functions. In this, first function is onto function. This onto function also called as subjective. This onto function also called as subjective. Okay, what is meant by onto function? A function f maps a to b is said to be onto if every element in codomain is nothing but B having at least one preimage in domain. Listen, every element in codomain having at least one preimage in domain. So this is called onto function. So this definition can be explained in another method. Why? Because we are using the second definition in problems. Okay. So what is the second definition? You observe. For each y belongs to capital B, then there exists x belongs to capital A such that f of x is equal to y. It is also definition for onto function. For each y belongs to capital B is nothing but every element in codomain. Then there exists a pre-image in domain such that f of x equals to y. So this is called onto function. I will give small example for onto function. This is set A. This set A having three elements. 1, 2, 3. Next, I am taking one more non-empty set, that is set B. Now this set B having four elements, 4, 5, 6, 7. Now 1 is related to 4, 2 is related to 5, 3 is related to 6. You need to check this function is onto or not. This is not onto function. Why? Because every element in codomain having at least one pre-image in the domain. So listen, 4 having pre-image, 5 having pre-image, 6 having pre-image, but 7 is not having pre-image. So this is not considered as onto function. For example, if you remove 7, now it can be considered as onto function because every element in codomain having at least one pre-image in the domain. For example, here I am taking 7. Now this 7 is related to 6. It is also called as onto function. Why? Because 4 having one pre-image, 5 having one preimage, 6 having 2 preimages. That's why in definition I mentioned at least one preimage will be exist in the domain. So this is called onto function. It is also called as subjective function. After that, next definition is bijective function. What is meant by bijective function? Bijective function is very simple. A function f maps A to B is said to be bijective if f is both 1 1 and onto. Understood? So a function which is both 1 1 and onto, that function is called bijective function. So this is a explanation about onto function and bijective function. Next definition is greatest integer function. Already in first PUC we discussed about this function. It is also called as step function. It is also called as step function. Why? Because the graph of this function is in steps manner. That's why it is called step function. Okay. What is meant by greatest integer function? Now listen. Greatest integer function is a function. So greatest integer function is a function which returns the greatest integer, less than the argument of the function. Less than the argument of the function. This is definition of greatest integer function. It can be written as f of x is equal to, how to pronounce this one? Step x. F of x equals to step x, where the step x less than or equals to x. Okay, I'll give a small example to find the step values of different values. For example, step of 2.1 is nothing but 2. Why? Step function always gives preceding integer. Now, step of 0.6 is nothing but 0. Step of 1.4 is nothing but 1. Step of minus 1.4 is nothing but minus 2. Step function always gives the preceding integer. Now, we will discuss the graph of this step function. See, these are the coordinate axes, x-axis and y-axis. This is 0, 1, 2, 3 and so on. Here, minus 1, minus 2. Here, minus 1, minus 2. Here, 1, 2. This is y-axis and this is x-axis. Now, the graph of step function is like this. If you take any value between 0 to 1, the answer will be 0. Next, if you take any value between 1 and 2, the answer will be 1. If you take any value between 2 and 3, the answer will be 2. If you take any value between minus 1 to 0, the value will be minus 1. If you take any value between minus 1 to minus 2, the value should be. Now observe the graph of this function is in steps manner, that's why it is called step function. Now we will discuss what is domain and what about range. Domain is nothing but what is the input we are giving. See, here I took 2.1, 0.6, 1.4, minus 1.4. You can give any real number. That's why the domain of this function is capital R. But you observe the output in the sense range. These outputs are not having decimals. Decimals in the sense answer will not give 2.1, 3.1. Only answers are integers. Why? Because step function always gives the preceding integer. These integers are denoted by Z. Therefore, the domain of this function is capital R, is nothing but real numbers, and range of the function is capital Z, is nothing but integers. So this is greatest integer function.